Hello, I'm Miss Igo. Welcome to my classroom. Today we're going to talk about operations with polynomials. The first operation that we're going to do with polynomials is addition. Here we have two sets of polynomials that are to be added together. Before we can add any of the terms in our polynomials, we have to get rid of parentheses first. Now, when you see a plus or a minus in between any groups of polynomials, we know that that means that they're being added or subtracted. If the two parentheses are touching, that's when we would multiply. So we're not going to multiply these two groups together. We're only going to add them. But like I said, first we have to get rid of the parentheses. This first group has a 2 that's touching the parentheses, which means we need to distribute that 2 into the parentheses in order to get rid of the parentheses. And we distribute, and when we distribute, the operation that we use is multiplication. So the 2 will get multiplied times the x. That leaves us with 2x. And then 2 times negative 3 would be a negative 6. Now, anytime we have a plus sign in front of a set of parentheses, we're distributing the plus, but that doesn't change anything because if I multiply a positive times a positive, it would stay positive. If I were multiplying a positive times a negative, then the sign would stay negative. But here we have another positive. So it's not going to change any signs. We can just drop the parentheses. Once the parentheses are gone, then we can combine like terms. Remember, like terms mean that the terms have the same variable with the same exponent, or no variable at all. So when I look at all of my terms, I have these two like terms here with the x's, a 2x and a 3x. And so when I combine those, I get 5x. And whenever we are simplifying a polynomial, we need to write our answer in descending order, which means we go from the highest exponent to the lowest exponent. Or in this case, we have an x with an understood 1, and then the constants wouldn't have any x. So the x would go first, and then the constant last. So now let's combine these like terms. We have a negative 6 and a positive 6. Well, negative 6 and positive 6 is 0. So when I combine those, I just get 0. So my answer whenever I combine these like terms, or when I add these polynomials, is simply 5x. Our next operation is subtraction. So once again, we have two polynomials, and they're separated by either an addition or a subtraction sign. In this case, it's a subtraction sign. So that tells us that we will not be multiplying these groups. We're adding or subtracting them. And again, before we can do anything, we have to get rid of the parentheses. This first set of parentheses doesn't have anything in front of it. So that means we can just drop the parentheses. But the second group has this negative in front. Anytime we have a negative sign in front of a set of parentheses, think of that as a negative 1. So we need to distribute the negative or the negative 1 into the parentheses using multiplication or the distributive property. Negative 1 times 2x, that would be a negative 2x. Then negative 1 times negative 3y would become positive 3y. Once again, we're going to combine our like terms. 5x minus 2x would be 3x. And then 3y plus 3y would be a plus 6y. And that's as far as we can go because those are not like terms, so we cannot combine them. So that means my answer is 3x plus 6y. Our next operation is multiplication. In this case, we're going to be multiplying a monomial times a binomial. And just like earlier, when we had something in front of the parentheses, we're going to distribute that term into the parentheses using the distributive property, which means we're going to multiply. So we multiply 4x times x. Anytime we multiply variables, we add the exponents. So there are little understood ones for our exponents on the x's. So when we multiply 4x times x, that gives us 4x squared, because x times x is x squared. And then 4x times 7 would be 28x. Now, if these terms were like terms, we would combine them, but they're not like terms because this x has a power of 2 and this x has a power of 1. So they have to have the same variable with the same exponent in order to be like terms. And we can only add or subtract terms that are alike. Now we're going to multiply a binomial times another binomial. Whenever we're doing this, we're actually using the distributive property, but we use it in a manner that makes sure that we don't forget any terms that need to be multiplied. And so to do that, we use FOIL. And that FOIL is just an acronym, like I said, that we use to make sure that we don't forget any terms. So what that stands for is first, outer, inner, last. So when we distribute the first term times the other first term, that's where the first comes from in FOIL, we get x times 2x, which would be 2x squared. Next, we'll multiply the outer two terms, which is x times 7, and that would be a plus 7x. The I in FOIL stands for the inner terms, and that gives me a negative 6 times positive 2x, which would be a negative 12x. And then the last two terms are a negative 6 and a positive 7, so that would give me a negative 42. If I had drawn this a little neater, let me do this. To me, this always looks like a smiley face. Like that's the mouth, that's the nose. We have two eyebrows over our eyes. But that's how we perform FOIL. But we're not done. I can see that in the middle, we have two like terms. So anytime we have like terms, we need to make sure that we combine them if we're told to simplify. And again, we want to write our answer in descending order according to the exponents. So that means the biggest exponent, the x squared, that term needs to go first. So we have 2x squared. And then when we combine these like terms, a positive 7x and a negative 12x give me a negative 5x. And then lastly, we would have a negative 42. So our answer is in descending order according to the exponents. All of our like terms are combined, so this is my answer. Here's another example of two binomials that need to be multiplied. Just to touch back on what I said at the beginning, if you'll notice, these two groups of parentheses, these binomials, they're touching each other. So that's how we know when we need to multiply the binomials. If there was a plus or a minus sign in between these binomials, then we would need to either add or subtract, not distribute. But because they're touching, we will distribute and do FOIL to make sure that we multiply all of the things that need to be multiplied times each other. Okay, so We'll multiply the first two terms together, and that gives me 4x times x, which is 4x squared. Then the outer two terms, 4x times negative 5 would be a negative 20x. The inner two terms give me a plus 3x, and the last two terms are a negative 15. Now my two middle terms again are like terms. So let's bring down the 4x squared. Combine the like terms, negative 20x plus 3x would be a negative 17x, and then minus 15. And that's my simplified answer. Okay, in this last example, we have a binomial 7y minus 1 squared. First, I'm going to show you what not to do. When we have a number, a whole number, in front of a set of parentheses, we distribute that into the parentheses. But when we have an exponent, we do not distribute that exponent into the binomial. You have to first remember what it means when something is squared. When we square a number, that means we multiply it times itself. So it's the same thing when we're dealing with a binomial or any polynomial. That means that we take that, whatever is being squared, in this case 7y minus 1, and we have to multiply it times itself. Okay, so now you see we have two binomials. So we need to multiply the two binomials. We're going to multiply the first two terms together. That gives us 49y squared. The outer two terms, 7y minus times a negative 1, gives us a negative 7y. And then negative 1 times 7y would give us another negative 7y. And negative 1 times negative 1 would be a positive 1. All right, when I combine my like terms, I get 49y squared minus 14y plus 1. So if I had distributed this power, this exponent, into our binomial, I would have gotten 49, if 7y squared, if I squared the 7y, I would get 49y squared. And then if I squared 1 squared would be plus 1, but it would be missing this middle term. So that's why it's wrong if you just try to distribute the square into the binomial. Remember that that always means take the binomial and multiply it times itself. And this is my solution. So that's how we do operations with polynomials. Thank you for watching.